Hello everyone, and welcome to another fun-filled class of science on e-learning. Today we're going to look at non-renewable energy. Like I said in the last video, we're going to flip-flop a little bit. Last class was wind energy, a renewable energy source. Today we will cover all non-renewable energy and then go back to our renewable energy sources. So we've got a lot to cover today. Let's get started. So our objectives: what is non-renewable energy? What are the specifics of the different types of non-renewable energy? What are the positive and negatives of non-renewable energy? So we've talked about this before, but non-renewable energy are called fossil fuels, and they include coal, petroleum or oil, natural gas, and uranium. Now, uranium is a little different. We won't cover that today, but uranium is used in nuclear energy, nuclear power energy, which is a renewable energy source. However, in nuclear power plants on the Earth, we use uranium. Uranium is a non-renewable energy source. Okay. A little confusing. A little nuance there, but we will talk about why that is a different type of energy source when we get to nuclear power later in the term. So again, we've covered a lot of this, but what is non-renewable energy? Well, they're called non-renewable because they take millions of years to form, and they cannot be replenished or replaced in a short period of time. Now, because non-renewable energy sources are finite, because they're limited, we could run out of these sources. So, you can look to the right here at this diagram to see how over millions of years, hundreds of millions of years, coal and oil and gas formed. But let's break it down a little bit more. First of all, coal. Now, we talked about coal last term when we talked about rocks and minerals, so I hope you remember. But coal is a sedimentary rock which comes from the remains of plants that died 100 to 400 million years ago. So you see the little picture there? These ancient forests lived, they died, they were buried and compressed, and over hundreds of millions of years, they formed into coal, that sedimentary rock. Now, we use coal to create electricity by burning it. And when we burn coal, we generate steam and we drive a turbine. Okay, like we had talked about before. Now, coal is also used in the iron and steel industry to get metal from ore, or to get metal from rocks, okay, essentially. Pretty critical when we talk about the need for things like steel, okay? Now, coal is primarily made up of carbon, okay? Because again, it comes from the remains, right, of plants. But it also contains the element sulfur. When coal is burned, that sulfur combines with oxygen in the air to form sulfur dioxide, SO2. Now, sulfur dioxide is a gas that is bad for air quality and bad for the environment. Now, we're talking about basically when we burn it, but also extracting, getting coal from the ground can be dangerous for the environment as well. But we won't get into that today. If you're interested in it, we can talk about it though. Next, petroleum. Petroleum or oil is formed when the remains of small sea animals and plants sank to the bottom of the ocean. Again, some small sea animals and plants sank to the bottom of the ocean. Now, over the next hundreds of millions of years, pressure and heat broke down this organic, this living or once living substance into compounds of hydrogen and carbon atoms. We call this hydrocarbons. So again, this organic substance from the animals and the plants were broken down into hydrocarbons. Petroleum is found deep below the Earth's surface. Okay, typically wells are 1,800 to 6,000 meters deep, and they produce 10 to 15 barrels of oil per day. Now, oil refineries clean and separate the petroleum. Now, if you look at the bottom left picture, that's an oil refinery, and it's cleaning and separating the petroleum. It's separating it into gasoline for cars, diesel fuel for trucks, heating oil for homes, and jet fuel for airplanes. In addition, petroleum is also used to make petrochemicals. Petrochemicals are used to make plastic. Okay, so that plastic water bottle you buy from 7-Eleven is made up of essentially petroleum, petrochemicals. Now, if we look specifically at Thailand here, in 2018, Thailand produced approximately 485,000 barrels of oil. So Thailand in 2008 pulled out 485,000 barrels of oil from deep below the earth. But the country used 1,478,000 barrels per day. Okay? So Thailand is generating quite a lot of barrels per day, but using 3 times as much. So they're also importing or bringing in oil to use. Petroleum can do damage to the environment, as we know. Burning gasoline contributes to air pollution. Processing petroleum at refineries contributes to air and water pollution. Drilling and transporting or moving oil can endanger the environment, wildlife, and ecosystems if spilled. If we look at the pictures here, the bottom left picture is of an oil tanker which has wrecked, and you see that the oil is spilling out of it onto the beach. Okay, very dangerous. All right. If we look at the middle picture, we see a bird. Not sure what type of bird, but it's coated in oil. Okay, when a bird like this gets oil on its skin, it can't clean itself. It can't fly. It can barely move. So thankfully, when these instances occur, we have people that do try to rescue and save animals. On the right-hand side, of course, we have an infamous bus here, and that black smoke that comes from buses or cars or trucks is the remnants or the remains of burning that petroleum in the engine of the car or the bus or the truck. Next, natural gas. Natural gas also similarly formed from the remains of small sea animals and plants that lived 300 to 400 million years ago. While natural gas is a mixture of several gases, the primary gas is methane, CH4. Now, methane is a natural compound that forms when plant and animal matter decay, when they break down, when organic substances break down. Now, methane has no smell, it has no color, it has no taste, and it can be deadly in high concentrations. Now, as you can guess, like oil or petroleum, natural gas is found in rocks deep underground. But it's also found in landfills where decaying garbage naturally produce methane. Okay? So in landfills, this organic material, let's say the trash from vegetables or meat or restaurant trash, okay, is slowly breaking down and releasing methane as it decays. Now, we won't get into this, but it's possible to capture that methane from landfills and use it to generate electricity. It's also quite necessary because escaping methane can be dangerous to the surrounding area. Okay? It can catch fire. Right? As we just saw, it can be deadly in high concentrations because we can't smell it, we can't see it, we can't taste it. Okay? So it's important to manage that methane appropriately. We use natural gas to generate electricity and to heat buildings in colder climates. Natural gas can also be used in cars and trucks if cooled to negative 260 degrees Fahrenheit. When this happens, it's called liquefied natural gas, LNG. You may see this around Thailand, actually. I think quite a few of the taxis use LNG to drive around. Now, natural gas does release carbon dioxide into the atmosphere when burned. However, burning natural gas produces less sulfur, less carbon, and less nitrogen than other fossil fuels like coal or petroleum. And this makes it the most environmentally friendly fossil fuel. Still not good, let's be clear, it's still not good for the environment, but it does less damage than coal or petroleum, okay? Which is important when we consider the overarching need to reduce pollutants. Next here, propane, chemical compound C3H8. Propane is a gas found in natural gas and petroleum. So when we process or clean natural gas or petroleum, we can take out the propane. So it's used to heat buildings in colder climates. It's used for cooking, to operate equipment, to cut or attach metal, and to make plastic products. The picture on the left there, again, this individual is attaching metal using a propane torch. Okay, creates very hot temperatures to melt and bind or attach metal. You may have seen this also. I tend to see it walking around near building sites or things like that. On the right hand side, got the famous walk of a street vendor. Okay, most of those street vendors you see are using a propane stove to cook on. You might even use propane at home to cook. Okay, so now you know where it comes from and how it's used. All right, finally, let's think about the positives and negatives of non-renewable energy. First of all, the positives. These are high energy density. This means they are very energy efficient. We can make a lot of electricity by burning them. Much more electricity than renewable energy sources. They also have many uses: energy, transportation, industry, creating plastics, and yes, even cosmetics. Okay, so the makeup you put on your face or the lipstick you put on your lips might, and more than likely does, have some pieces or particles of non-renewable energy. More than likely petroleum. The negatives, though, non-renewable energy sources are sources of pollution: air pollution, water pollution, soil pollution, because of the carbon, the methane, the sulfur, and other chemical components they release when used, specifically when they are burnt. Okay, we see that first. I should say both of these pictures show burning non-renewable energy sources and the dark smoke that comes from them. The second negative is that these are sources of global conflict, what are called geopolitical issues. Okay? Wars get started trying to seek resources, oil or coal, let's say, and can create a lot of issues for countries and regions. If you're interested in this, again, we can talk about it if you'd like. So, ladies, I know this again was a long class, but we did go over a lot today. We won't be returning to non-renewable energy. I hope you took away a lot of information from this and completed your worksheet. Again, if you have any specific questions, I will be happy to answer them for you in class. But make sure you finish the attendance question. That is critical, okay? And I hope you have a good day. Thanks, and bye-bye. See you soon.